Hello and welcome to today's lesson. In our previous lesson, we looked at how we can be able to find the gradient of parallel lines, and we established the relationship of the gradient of parallel lines as M1 is equal to M2. That means when two lines are parallel, they have the same gradient. We went ahead and obtained the equation of a line which is parallel to another given line if you are given a point where the line is passing through. So in today's lesson, we want to extend the discussion to perpendicular lines. So in this particular discussion, we need to understand that perpendicular lines have common place in mathematics and in the world around us. You will notice that perpendicular lines can be used to construct rectangular shapes, which are very useful in building and construction in modern structures. So if you want to construct a modern structure, you will discover that the beams can be placed at right angles to each other. That means the beams can be perpendicular to each other. So that means this concept of perpendicular line has applications in real life situations. So in this particular lesson, we shall first of all establish the relationship between the gradient of perpendicular lines. Then secondly, we shall be able to use that particular relationship or the rule to find the equation of a line which is perpendicular to another given line and passing through a specific point. So let us first of all look at the relationship or establish the relationship between the gradient of parallel lines. So to establish the relationship between the gradient of parallel lines, we shall consider two lines. That is line 1, whose equation is y is equal to 2x minus 2, and line 2, represented as L2, whose equation is y is equal to negative a half x minus 1. So we wish to plot this line 1, and for us to plot line 1, we require a table of values. We first of all choose a value of x. In this case, we can let the value of x to be 0. Then replace in our equation, which is y is equal to x minus 2. So if we place where there is x with 0, we realize that the value of y is negative 2. We choose another value of x. Suppose the other value of x is 1. So when the value of x is 1, y will be 2 times 1, which is 2, minus 2, which gives us a 0. So the value of y is 0 when x is 1. Then we go for table 2. For line 2, again, for line 2, we introduce a table of values. we choose the value of x to be 0. When the value of x is 0, the y value will be a half times 0, which is a 0, minus 1, which is negative 1. Then we choose a value of x to be 2. When the value of x is 2, the value of y will be negative a half times 2, which gives us negative 1. Then we subtract 1, which gives us negative 2. So when x is 2, the y value is negative 2. So you realize that we have chosen the value of x to be 2 because 2 is divisible by 2. So that we only have integers, integral values. So from these tables, we can be able to plot the points. So the first point to plot will be 0, comma, negative 2. And the second point for table 1, that is for line 1, will be 1, 0. Then the points to plot for the table whose equation is y is equal to negative half x minus 1 will be 0, negative 1 will be the points we plot. And the second point to plot is 2, comma, negative 2. So let us start with the first line whose equation is y is equal to x minus 2 and represent it on the Cartesian plane. So in our Cartesian plane, we have the y-axis, which is the vertical axis. We have the x-axis, which is the horizontal axis. The two axes intersect at the origin. So the first point is 0, negative 2. When x is 0, the y value is negative 2. That means that is y-intercept. When x value is 1, y value is 0. That means x-intercept. We now join the 2 points using a ruler. Then we identify that line as line 1. So the equation for that line 1 is y is equal to 2x minus 2. We go ahead and plot the points for line 2. That is, the first point is 0, negative 1. Then the second point is 2, negative 2. 2 is along the x-axis. We now go ahead and join the 2 points using a straight line. We now join the 2 points using a ruler to obtain the straight line. Then once we have our straight line, we indicate it as line 2. And the equation of line 2 is y is equal to negative a half x minus 1. Now, the 2 lines meet at right angle. You can confirm that by using a protractor. You'll notice that the 2 lines meet at right angle. So we say that line 1 is perpendicular to line 2. So this symbol means perpendicular. So line 1, L1 means line 1, perpendicular to line 2. Now, let us establish the gradient of line 1. To read off the gradient of line 1, we compare with the general gradient intercept form of a line. Y is equal to mx plus b. So our line 1 is y is equal to 2x minus 2. So what is the gradient of that line 1? So that means the gradient of line 1 is the coefficient of x. And in this case, the coefficient of x is 2. So we can be able to say m1 is 2, where m1 represents gradient of line 1. So what will be the gradient of line 2? So the gradient of line 2 again will be the coefficient of x. In this case, the coefficient of x is negative a half. So we must link the coefficient of x with the negative. We link that gradient with the negative. So if the gradient of line 2 is represented by m2, then we can be able to say that the gradient of line 2, which is m2, is equal to negative a half. So we now write down the relationship between the gradient of perpendicular lines. So if we take 2, multiply by a half, negative a half, the result is negative 1. But you need to notice that 2 is the gradient of line 1, which is M1, and negative a half is the gradient of line 2, which is M2. The result is negative 1. Now, we can be able to write down that relationship as follows. If two lines are perpendicular, then the product of their gradient is equal to negative 1. For perpendicular lines, the product of their gradient is equal to negative 1. That is, M1 times M2 is equal to negative 1, where M1 represents the gradient of line 1, and M2 represents the gradient of the second line, which is perpendicular to the first line, L1. That means if you have been given the gradient of the first line as M1 is given, then you want to get the gradient of line M2, or the gradient M2 of the second line. So the gradient of the first line M1 is given, and the gradient of the second line, which is M2, is unknown. That means it's not given. You now write down the rule. M1 times M2 is equal to negative 1. This implies that to get the gradient of the second line, M2, we find the reciprocal, the negative reciprocal of the gradient of the first line. So that means M2 is equal to negative 1 over M1. That is the negative reciprocal of the gradient of the first line. So this will be very useful in our subsequent examples. So let us now look at an illustration which can assist us be able to solve questions involving lines that are perpendicular. Let us now look at this illustration to assist us solve questions involving equations of perpendicular lines. So in this particular example, the question reads, find the equation of a line which is perpendicular to the line y is equal to 2x minus 3 and passes through the given point 0, negative 1. Now, how do we solve this particular question? So it's very important for us to assign line 1 as so line 1 is L1 and its equation is y is equal to 2x minus 3. So from this line 1, we can be able to get the gradient by comparing with the general equation of a straight line. Y is equal to mx plus b, where m represents the gradient and is the coefficient of x, and b represents y-intercept. Now from this particular equation of line 1, we can be able to read off the gradient. So the gradient is m1, which will be 2. So we can be able to get the gradient of the second line, which we can call m2. For perpendicular lines, m1 times m2 is equal to -1. So in this case, m2 is equal to -1 over m1, which is -1 over 2. That is m2. So we are saying m2 is -1 over m1, which is -1 over 2, because m1 is 2. Then, to get the equation of a line, we also require the y-intercept b. So already, we know that m is -1/2 for our second line. B, which is y-intercept, from the point here, the y-intercept is -1 since the x-coordinate is 0. And we did mention that when the x-coordinate is 0, then it means the point is y-intercept. So in this case, our y-intercept will be -1. Alternatively, to establish that b is -1, we can be able to do substitution. Substitute the point. The point is the value of y is -1. Gradient we have established is -1/2. The value of x is 0. Plus b. So from this particular substitution of the values of the point x as 0 and y as -1, we find that the value of b is -1. So it is corresponding to what we have just mentioned, that the moment you have a point 0, -1, then the y-coordinate represents the y-intercept. So the y-intercept here is -1. So there was no need for us to go to this method, but for clarification, it's important to understand how we can be able to identify y-intercept as -1 if you are given a point. So once we have the gradient -1/2 and the y-intercept as -1, we substitute in the general equation of a straight line. So that means that if we substitute m to be negative a half, which is the gradient, and b, that's y-intercept, to be negative 1, in the general equation y is equal to mx plus b, the final equation becomes y is equal to, where there is m, we replace with the negative a half, then x, where there is b, minus 1. So that will be the equation of that perpendicular line. So we now say, or answer the question as follows. The equation of the perpendicular line is y is equal to negative a half x minus 1. And that's the solution to that particular example. Let us now look at another example. Find the equation of the line that is So in that particular example, 2, you are required to find the equation of the line that is, part A, perpendicular to the line with the equation y is equal to 5x minus 4, and passes through the point 1, 6. So let us look at how we can be able to find the solution, or to find the equation of a line which is perpendicular to the given line. So the first thing we can do is to come up with a sketch. In our sketch, we have 2 lines. The first one is y, and the second one, we don't know its equation, so we put there a question mark. So the lines are passing through the point 1, 6. That means the point where the line is passing is 1, 6. Now what we do, we first of all establish That is, the line 2 is passing through the point 16. We first of all express the equation in the form y is equal to mx plus b. In this case, for line 1, y is equal to 5x minus 4. That means the gradient m1 will be the coefficient of x, in this case is 5. Then, because the two lines are perpendicular, indicated with by that symbol, it means we apply the rule for perpendicular line, and we did mention that if two lines are perpendicular, then the product of the gradient is equal to -1. So m2, that is the gradient for line 2, will be -1 over m1, which is equivalent to -1 over 5, and that is the gradient for m2. So once you have the gradient m2, we need to get b. That is the y-intercept, the point where our line crosses the y-axis. So to get the b part, the b, which is the y-intercept, we substitute the point 16 in our relation. Substitute m is 1 over 5, x is equal to 1, y is equal to 6 in equation 1. So equation 1 is y is equal to mx plus b. So we are going to carry out substitution. Where there is m, we put there -1 over 5, which is the gradient. Then where there is y, we put there 6, which is the point where the line is passing through. Then where there is x, we put 1. That means where there is y is 6, m is -1 over 5, x is 1, and b is unknown, is what we want to find out. So we simplify. So to find the value of b, we add 1 over 5 on both sides. So that means we shall have on the left 6 plus 1 over 5. Then on the right, -1 over 5 plus 1 over 5. That leaves us with a 0. So the value of b is 6, 1 over 5 as a mixed fraction, but we can be able to express it as an improper fraction. 5 times 6 is 30, plus 1 is 31. So as an improper fraction, The value of b will be 31/5. So we now replace where there is m with the -1/5 and where there is b with 31/5. So substitute m is equal to -1/5, b is equal to 31/5 in equation 1. So substitute m is -1/5, b is equal to 31/5 in equation 1. So that implies so the equation of that perpendicular line is y is equal to -1/5x plus 31/5. So basically, that's how we find the equation of perpendicular line. Let us look at example 2, part B. Now, in part B, you are required to find the equation of the line that is part B perpendicular to the line with the equation y is equal to -x minus a half and passes through the point -2, 3. So the first thing, we write down the equation of line 1 . So once we have written down the equation of line 1, which is y is equal to -x minus a half, we compare with the general equation of a straight line. Compare. So when you compare with the general equation y is equal to mx plus b, it means that the gradient of that line 1 is, we need to know that 1 is implied here. So -x, it means there is a 1. Because -x can be written as -1x. That means the gradient for that particular line 1 is -1. Once we know the gradient of the first line, we can be able to get the gradient of the second line, which is perpendicular to line 1, by applying the rule m1 times m2 is equal to -1. That is, the product of their gradient is -1 since the two are parallel. So from here, we can be able to express m2, that is make m2 the subject, which is -1 over m1. If we substitute the value of m1, which you have obtained as -1, we obtain the value of m2 to be 1. Therefore, the gradient of the second line is 1. So the gradient of that second line is 1. We look at now, we write down the general equation. Y is equal to mx plus b. We have the gradient m, which is 1, but we don't have the y-intercept b. So how do we find b? To find b, which is y-intercept, we substitute the values of the point in our linear relation. So suppose we call this linear relation y is equal to mx plus b, which is our general rule, to be equation 1. We are saying to find b, which is the y-intercept, substitute the point -2, 3, and the gradient m is equal to 1 into that equation 1. That is, where there is y, we put there 3. Where there is m, we put there 1. Where there is x, we substitute with the -2. Plus b, which is unknown. We now simplify. On the right hand side, we have 3. 1 times -2 is -2. Plus b, which is unknown. Now to get b, we add -2 on both sides because we have -2. So we shall add 2 on both sides, +2 on both sides. So on the right hand side, we have 3 plus 2. And on the left hand side, we have 3 plus 2. On the right hand side, we have -2 plus 2, which is a 0, plus b. So in short, it will be so 3 plus 2 is 5, -2 plus 2 is a 0. Now, in our third example, we are required to write down, you write the equation of the line perpendicular to y is equal to -3 and passes through the point 2, 0. So in this particular example, you first of all sketch so that you have an idea on the behavior of the line. So for the line y is equal to -3 is usually a horizontal line parallel to the x-axis. So this is our line. This is the line y is equal to -3. Is a horizontal line parallel to the x-axis. So we did mention that if the line is horizontal, the gradient is 0. How is the gradient 0? From the definition of gradient, rise over run, it means in this situation there is no vertical movement, so the rise is 0 divided by any value of the run. So 0 divided by any value, the result is 0. That's why the gradient of a horizontal line is 0. So we had mentioned that during our previous lesson. So if the line is horizontal, it means the line which is perpendicular to it must always be vertical. So a vertical line is always perpendicular to a horizontal line. So the two lines are always perpendicular. That's vertical and horizontal. And therefore, if the horizontal line has an equation, y is equal to -3, it means the equation for the vertical line must always be x is equal to. So we read off the x coordinate. So in our case, the line is passing through the point 2, 0. So the first line is passing through -3. That means y is equal to -3. Now the second line is passing through the point 0 to 0. That means it's a vertical line. It must be a vertical line for it to be perpendicular to the horizontal line y is equal to -3. So for the vertical line, we read off the x coordinate, which is 2. So the equation of that vertical line will be x is equal to 2. So the moment you have a horizontal line, to get the equation of a line which is perpendicular to that horizontal line, we need to know that the line must be a vertical line for it to be perpendicular to the horizontal. And therefore, we only read the x value. In this case, the equation of the line will be x is equal to 2. So we only read the x values. The equation of the line perpendicular to y is equal to -3 is x is equal to 2. Now, in summary, we can say that we have looked at how we can be able to find the gradient of our perpendicular line, and we have established the relationship between the gradient of perpendicular lines as m1 times m2 is equal to -1. That is, the product of the gradient is -1. We have also gone ahead and discussed how we can be able to determine the equation of a line which is perpendicular to another line and passing through a given specific point. We have said that for us to determine the equation of a line perpendicular to another line, we need first of all to write the general equation of a straight line, which is y is equal to mx plus b. Then substitute the value for m, which is the gradient, and also find the value of b, which is the y-intercept, and finally substitute in that particular linear relation. Thank you.